Hey guys, this is 9.10 for Calculus BC, and we are closing up with our last lesson on Taylor series. So I know we've seen our Taylor polynomials, but now Taylor series, we're basically going to take the Taylor polynomials that we have memorized, which are the Maclaurin ones, and maybe some other ones, and we're just going to start manipulating them a little bit, okay? So in order to solve, we're either going to do by hand the Taylor with the formula from 9.7. We're going to either bring about one of the memorized Maclaurins depending on what they've given us, and then we'll just apply that part of the function, the composite, and plug it in, okay? So check this out how easy it is. The first one says find the Taylor series at c equals 0 for f of x equals e raised to 3x. Now, to start off with, a Taylor at c equals 0 is really a Maclaurin, okay? Second, you know the Maclaurin for e raised to x. Okay, let's write that down. We have that memorized. So for e raised to x, I know that my Maclaurin is the infinite series of x raised to n over n factorial. So if I need to find it now for e raised to 3x, all that means is in here, wherever there's an x, I'm just going to plug in a 3x. It's as simple as that. So my x was here, so now I'm going to put 3x raised to n over n factorial, and you are done. It's that easy when it's one of the ones that you have memorized, okay? This gets a little lengthier when it's one of the ones you don't have memorized, but it is as simple as that. So let's take a look at a question that does take up more time. This is find the Taylor series at c equals 2 for f of x equals 1 over 1 minus x. So to begin with, it is definitely Taylor. It's at c equals 2. It's not a Maclaurin. And my function 1 over 1 minus x, I don't have memorized. So I am going to go through the motions of the Taylor, okay? And it will refer back to 9.7 in that formula for Taylor. The first step is to find the function's derivative at c, right? So I'm going to start off with just a few terms. In this case here, f of x, I'm going to rewrite this and bring this up as 1 minus x to the negative first. It's going to be a lot easier to start doing my power rules. Then the derivative here is going to be to multiply that negative 1 to the front, rewrite the inside, subtract 1 times derivative of the inside is a negative 1. So I'm really left with 1 minus x to the negative second. I'm going to multiply that negative 2 to the front, rewrite, subtract 1 from the exponent, times the derivative of the inside. It's going to turn that to a positive 2 times 1 minus x to the negative third. And let's do one more. So now if I multiply that up front, I have a negative 6 times derivative of the inside. You guys are catching the pattern hopefully by now. Okay, so now let me draw a line here just so we don't mix up our work. Now I'm going to do all of these at 2. F of 2, f prime at 2, f double prime at 2, and f triple prime at 2. So if I'm plugging that in, I have 1 minus 2 is a negative 1. So I end up with negative 1 to the negative first. Remember that that negative exponent just takes it down to the bottom, which is just negative 1, guys. Now here, same exact thing. Well, let's look at this one. But it's to the negative second. So it is going to bring it down, but that square is going to make it positive. So are you catching the pattern that that odd number made this a negative 1 and that even made it a positive 1? Now notice that my insides here are all the same, and what is changing is my exponent and then a coefficient on these next two. So notice that when I had an odd exponent like this one, I ended up with a negative 1. So it'll be that 2 that inside is going to give you a -1, which leaves me with -2. Now here I have a coefficient of 6, and I have an even exponent. That even exponent ended up giving me a +1. So this is 6. Okay? And now I'm ready to plug this into my Taylor. So my Taylor begins with, I have when n equals 0, we'll then do when n equals 1, when n equals 2, and we'll get all the way down to when n equals 3 and see if we can come up with an nth term based off of that. So when n is 0, my coefficient is -1. Then according to my formula for Taylor, I have x minus c, c is 2, raised to n, which is 0 over n factorial. Next, the coefficient for n equals 1 is 1 x minus c raised to n over n factorial. Next one, I have a -2 x minus c raised to n over n factorial. And then lastly, I have a 6 x minus c raised to n over n factorial. Let's take a minute and clean this. 0 factorial is 1. Anything raised to 0 is 1. So this portion here is 1 over 1 times a -1. Then here, 1 factorial is 1. This is 1 over 1. I'm left with x minus 2 raised to the first power. Here I'm going to bring this negative to the front. And then notice that 2 factorial is 2 times 1, which equals 2. So those 2's are going to cancel. And I'm just left with x minus 2 raised to the second power. I'm going to bring my plus sign. 3 factorial is 3 times 2 times 1, right? 3 times 2 is 6, times 1 is just still 6. So these 6's cancel. And now I have x minus 2 to the third power. And you can see that this is going to keep on. I put a minus because you can see that we're alternating negative, positive, and so on. So if I want to talk about what my series would be, I can see that I'm alternating signs, and I'm specifically starting at a negative. So if I want this to be negative, I need to know that when I plug in a 0, this is going to stay odd because odds keep negatives. And then when I plug in n equals 1, it's going to be even, so this is going to be positive. So for that reason, if I just put n, the odd ones would have been negative. But if I put in n plus 1, now my odd ones added to 1 will become even and become positive. And then I can see in each term that I have this x minus 2 and always raised to whatever n was. So there's none here raised to 0, to the first, to the second, to the third, and so on. And I just created my Taylor series. This next question says to find the first 2 terms of the Maclaurin series for tangent. So we have memorized the series for sine and cosine. You're going to have 2 different options here. I'm going to show you the shorter one. You could solve both sine and cosine, and then tangent is sine divided by cosine. But that might be a little lengthy with so many terms to do a division. So let's just try it out with tangent. Step 1 of the formula is to solve for their derivatives. So if f of x is tangent, and then I solve for tangent at 0, I know that tangent at 0 is 0. Okay, so that's going to cancel out my first term, multiplying by 0. So I know I need to keep going because I need to be able to get 2 terms. So f prime, derivative of tangent, is secant squared. Okay, now secant squared is like saying secant at 0 is 1, and I square it and I still get 1. So here's going to be my first term. Second derivative here, I need to do chain rule. I need to do, remember, this is like saying secant of x squared. So derivative of the outside, rewrite the inside, times derivative of the inside is secant tangent. So I'm going to rewrite this as 2 secant squared x times tangent. So when I try and do the second derivative at 0, the fact that I have a tangent in there and I already saw tangent of 0 is 0, it's going to cancel everything out, right? Because I'd have 2 times secant of 0 is 1, squared is still 1. But then if I plug the 0 into the tangent, that's 0, so this is just going to give me 0. So just to start marking things for you, this term got canceled out, this one I got 1, and this one got canceled out, okay? So again, if I need 2 terms, I need to be able to get at least another coefficient that's not 0, so it doesn't multiply my whole term by 0 and cancel it out. Let's go on to the third derivative, okay? I'm going to bring down my coefficient of 2, and now I have to do product rule. So I have first, which is secant squared, times derivative of the second, derivative of tangent is secant squared, plus derivative of secant squared, which we just did from here to here. So it's this exact answer. And then times the original of the second. Okay, so if I try to do f triple prime at 0, I'm going to have 2 times, we said secant squared of 0 was 1, times secant squared of 0 is 1, plus 2 times secant squared of 0 we said is 1. Tangent of 0 is 0, and tangent of 0 is 0. So this entire term is going to get canceled because of 0, but now I have 2 times 1, which is just 2. So I have 2 coefficients. I can keep going now. Now, according to the formula, right, I'm going to put I have to do this one to know that it's going to cancel and not mix up my ends. So if you do want a shortcut, I went up to 4 ends. Right? I'm sorry, 4 of them, so up to n equals 3. Be careful not to put the wrong exponents with the wrong coefficients. So if you know that this one and this one are going to cancel, then you could skip these and just make sure you put the correct ends. Okay, I'm going to write it all out just so we see it. We have this coefficient times x minus c. This is Maclaurin, so we don't have a c, raised to n, which in this case, sorry, is 0, over 0 factorial. This coefficient is 1. X raised to n over n factorial. This one's going to cancel out with a 0, but I have x raised to n over n factorial. And this coefficient is 2, x raised to n over n factorial. So, to clarify, this is getting multiplied by 0, it cancels. This one's getting multiplied by 0, it cancels. Be careful not to go straight from 1 to 2 and not have these correct ends, okay? Be very careful there. So this cleans up with my first 2 terms being x plus 2 over 3 factorial. Remember, 3 factorial is the same as saying 3 times 2 times 1. So this 2 and this 2 is going to cancel, and I'm left with 3 times 1. So I've got 1 over 3 times x cubed. And then this keeps on going. And it asked me for the first 2 terms. I've got my first 2 terms. I am done. Looking at this next question, find the Maclaurin series for f of x equals e raised to negative 3x. Hopefully you're seeing it's Maclaurin, it's e to the x. I have this memorized. This is easy, okay? So Maclaurin for e to the x, we know that the rule is the infinite series of x raised to n over n factorial. So if this is e raised to negative 3x, anywhere there was an x, I'm going to put a negative 3x. These should feel nice and easy. And yes, these do appear in the AP test, usually in the FRQs. And you are done with this one. This next question reads, if the Maclaurin series for ln of x is, and then they give it to you. So we weren't asked to memorize this one. For BC, you are asked to memorize sine, cosine, and e to the x. So here they were nice enough to give you what ln of x's Maclaurin series is. So it said, given that, now find what the Maclaurin series would be for ln of 1 plus x squared. So if this is the one for ln of x, but now instead of an x, I want a 1 plus x squared, I'm just going to plug that into the spot of the x. So everything else stays the same, but now instead of an x, I'm going to put 1 plus x squared. Keep writing the rest. Okay. So now I'm just going to clean whatever I can. I can drop these parentheses because I'm just subtracting by a 1, which means the positive 1 and the negative 1 are going to cancel. So in here I'm left with x squared raised to n over n. And the last bit of cleaning I want you to do is remember that an exponent raised to an exponent gets multiplied. So I have the infinite series. Keep all of this the same. Now I'm going to write x raised to 2n over n. And I'm done at this point. Let's check out the next one. Find the Maclaurin series for f of x equals 2 times sine of x cubed. Okay, so sine of x is one that we have memorized. So for sine of x, we know that my infinite series is negative 1 raised to n times x raised to 2n plus 1 all over this 2n plus 1 factorial. So now, I've got two things going on in here. I've got this 2. I'm going to literally just multiply to the front. And now in the place of x, I need to put an x cubed. Okay? You could do one at a time or you could do both at the same time. It really isn't that much. Okay? So I'm going to multiply the 2 right up front. And I could say 2 times negative 1 to the n. Now, remember, x is where I'm plugging this into. So now I'm going to say x cubed raised to 2n plus 1. And there's no x's down here, so this just stays the same. And now I'm just going to clean any bit that I can. So the proper way to write this, I'm going to put the alternating symbol up front. An exponent raised to an exponent, I multiply, and I'm going to put that 2 in front of the x. So I'm multiplying 3 to both terms here. Be very careful. 6n plus 3 over 2n plus 1 factorial. And now I'm done with my nth term, with my series. There's one more thing I want to show you, though. Okay? We know that the first few terms of sine are x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. What if they also ask you to write the first 3 terms of this? Well, if I know that that's how that starts to expand, now I'm just multiplying each of these by 2 and plugging in an x squared into each of these. So it would look something like 2, and now plug in my x squared, minus multiply a 2, plug in my x squared, keep writing the cubed over 3 factorial, multiply the 2, plug in an x squared, then write to the 5th over 5 factorial. And then just clean if you can, okay? So here, I know an exponent raised to an exponent, I multiply. So that's the first cleaning I'm going to do. And then some, depending on your question on the AP, whether it's multiple choice or FRQ, some of them clean these fractions and some of them don't, okay? So in this case, I'm not going to clean it. I'm just going to write you 2x squared minus 2 over 3 factorial. Exponent raised to an exponent, I multiply. Then plus 2 over 5 factorial. And then exponent raised to an exponent, I multiply. Okay, and then you can put your dot, dot, dot. And now you were also able to list the first few terms without having to actually solve all of that. Sorry guys, just caught a little mistake. I'm going to point them out to you and then I'm going to fix them. The question had an x cubed. I accidentally wrote an x squared over here. It was written correctly here, so this is not going to change. But when I wrote it here, I did write the x squared instead of the x cubed. So I'm going to change this to a cubed and these to a cubed, which are going to affect my final exponents. I'm going to erase them and then I'll put the screen back on. All right, so I've gone ahead and whited out the 2's that I put by accident. It was an x cubed, so I'm going to fix that one. I wrote it correctly here, which doesn't change this. This should have been a cubed, and a cubed, which would have made this one cubed. 3 times 3 is 9, and 3 times 5 is 15. I apologize for that. This is your final answer. All right, guys, we have our last question for this section and for this chapter. It is to find p sub 4 and the nth term of the Maclaurin series for f of x, which is equal to e to the x times cosine. So the nice thing about this is they are both two Maclaurins that we have memorized. So let's take a minute and write out what we have memorized. We know that e to the x, okay, is the infinite series of x raised to n over n factorial. And we know that the first few terms of that looks like 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And I'll write one more and just go to the fourth because this is going to be asking us for p sub 4 in a minute. Okay, now let's write out cosines. Cosine of x is the infinite series of negative 1 raised to the n times x raised to 2n. Remember, cosine is your even function, so we got that even 2n times 2n factorial. And a few of these terms look like 1 minus x squared over 2 factorial. We just do the e. It's pretty much the same as e, except it alternates and it's only the even terms, okay? Now, if we were to be adding or subtracting these, this would be really easy, but we are multiplying, okay? So, I've got to do two things. I have to find the nth term, which multiplying these two, and then p sub 4, which means I need to multiply these two. That part is a little lengthier, okay? So, bear with me. We're going to do the easy one first. We're going to multiply the nth term, okay? So, e to the x times cosine of x. I'm going to say the infinite series, and I'm going to say x raised to n over n factorial times negative 1 to the n times x raised to 2n over 2n factorial, okay? This is going to give me the infinite series. Here, if I'm multiplying, I have these two x's I combine. I'm going to write this alternating portion first. And now when I'm multiplying and I have the same base, I add the exponents. So I say x raised to 2n plus 1n is 3n. And then factorials, we cannot combine these in any way. So I'm going to write n factorial times 2n factorial. And we are done here, okay? This was the easy part. Now, if we want to find the terms we can multiply these two terms. So, I mean, this has plus dot, 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 and this has minus dot, 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 but we only want to the fourth. So we're going to be doing a little bit of foiling here. If I'm going to multiply now e to the x times cosine, and I have to FOIL, I'm going to choose to write my shorter one first, and you'll see why in a second. And that's going to be multiplied by the top one. Oops, sorry, that should be an x to the fourth over 4 factorial. Okay, so first I'm going to FOIL and distribute, FOIL or distribute, whichever one you like to hear, 1 times all of these. Now remember, I only care about p sub 4, so I'm going to stop anytime I get up to an exponent of 4. If I go beyond that, I don't need it, okay? So 1 times all of these is going to give me this exact same thing. Okay, here's where things are going to get a little more complicated. Now I'm going to multiply this term, this x squared over 2 factorial, to each of these. Remember, the moment you get up to an exponent of 4, you can stop, so you may not end up having to multiply to all of them. I'm also going to write it underneath so I can line up my exponents, okay? So this negative x squared over 2 factorial times 1, it's going to end up with an exponent of 2, so I'm going to write it here. And it's just going to give me itself. Now I'm going to multiply by x, which is just going to make this increase to an x cubed. So I'm going to have negative x cubed over, 2 factorial, right? Because I'm just multiplying it by x. Now, when I multiply this to the squared, right, negative times positive is negative. X squared and x squared make x to the fourth. And then 2 factorial times 2 factorial, that's just going to give me 4. Not 4 factorial, just 4. Since I got to an exponent of 4, I'm going to stop. And now I'm going to move on to my last term here and distribute. When I distribute it times 1, I get that exactly. I'm going to line it up. Be careful with the differences between 4 and 4 factorials and the different symbols, okay? Now, if I were to multiply this to the next term, I get x to the fifth, so I need to stop there. Now, I'm all about combining like terms. I can bring down the 1. I can bring down the x. Here, these two are identical, but with opposite signs, so these are going to cancel, okay? Now here, feel free to use your calculator. I am going to have that common term of the x cubed, and then you on your calculator can say a positive 1 over 3 factorial minus 1 over 2 factorial. That is going to give you a 3, okay? If you want to do it in your head, you know that 3 factorial, let me show you, is equal to 3 times 2 times 1, which is the same as saying 2 factorial, okay? So you can use that to help you get common denominators and clean this out, but you could also plug it in your calculator and the answer will give you 3. Lastly here, again, I know I'm going to have this commonality of x to the fourth, so I can just worry about the coefficients and in my calculator say a positive 1 over 4 factorial minus 1 over 4 plus a 1 over 4 factorial. It's going to leave me with minus x to the fourth over 6, and I am done there.